Hi, I'm Nick Femia.
And hi, I'm Tim Long.
Today we're going to be talking about fractals.
The dictionary definition of a fractal is an extremely irregular curve or shape for which any suitably chosen part is similar in shape to a given larger or smaller part when magnified or reduced to the same size.
In simple language, this means that it is a pattern in which the pattern repeats infinitely at different magnifications, and the pattern is identical when it is zoomed in or out to different sizes.
The modern concept of a fractal began to take hold in the 1600s with the work of mathematician, philosopher Gottfried Wilhelm Leibniz. In 1872, a function that was a fractal when it was graphed appeared. The function was created by Carl Weierstrass, and it was an example of a function that had the perplexing property of being continuous everywhere but differentiable nowhere.
In 1904, the mathematician Helge von Koch did not like this definition and defined a fractal more geometrically with his Koch snowflake. And here are 4 different variations of that Koch snowflake. As you can see, the image of the snowflake is right here. And if you were to zoom in on this segment, it has the same exact shape as the larger snowflake, but it is just a smaller in size. And you could do this to an infinitely small magnification when you zoom into this little piece right here, and that pattern will repeat infinitely if you zoom in to different sizes.
In 1915, Wojciech created what is known as the Sierpinski triangle and the Sierpinski carpet, which are both composed of fractal patterns. And as demonstrated here is the Sierpinski triangle, and it looks like a large triangle at first, but if you just zoom in at any of the smaller points at all, you would see the same pattern repeated infinitely throughout the structure. And this would be the Sierpinski carpet, and it demonstrates the same pattern as above, where like the larger image just looks like a square of a bunch of small squares, but when magnified in at any location, you see the same pattern throughout to an infinite magnification.
In the 1960s and 1970s, Benoit Mandelbrot furthered the concept of a fractal, and he coined the term fractal. Here's a picture of Mandelbrot.
And fractals appear all over the world.
They are naturally occurring fractals that appear in living organisms and in the natural environment. Fractals are best used to describe these patterns because they cannot be described otherwise using regular shapes.
For example, many flowers are fractals. The petals can be arranged in such a way that they have a repeating pattern when looked at segments of certain flowers at different magnifications. Also, snowflakes are naturally occurring objects that compose the fractals. And as demonstrated in this picture here, if you do zoom in on any of the petals, you see the same fractal structure throughout the whole flower, as if you do zoom out and look at the flower as one singular flower.
Additionally, other aspects of nature are also made of fractals, such as pine cones and broccoli. Furthermore, coastlines are fractals because the closer you get to a coastline, that coastline's measurement gets increasingly large due to its jagged nature, while the measurement can be smaller when measuring it from a greater distance. So it is impossible to precisely measure the length of all the grooves and irregularities that exist in a coastline with classical methods of measurement, which is due to the fact that coastlines are comprised of fractals. And that is a picture of the British coastline, which demonstrates that principle of having an infinitely large coastline.
Similarly, rivers are comprised of fractals, and since they have many jagged edges and grooves, it is also impossible to measure the exact distance of a coastline with classical methods of measurement.
This fractal can be demonstrated with the equation log of n over log of r, where n represents the value of the perimeter as it increases, and r is the magnification factor applied. And that is the equation.
And the universe is theorized to be made of fractals after scientists study statistical physics and the structure of galaxies and clusters.
However, fractals can be found in more than just nature. For instance, in computers, fractals are used to create JPEG and GIF file formats for images.
Also, the use of fractals help to prevent pixelization when zooming in on certain images. Additionally, they are used frequently throughout video games.
In video games of graphic design, fractals are used to create an endless view of the world in a game and in gameplay. Also, games can feel fractalish depending on the size of the world in the game, as you could be the only player to stand or play at a specific area in the game. And a prime example of this is in The Legend of Zelda Breath of the Wild, where you can see it has a very vast world, which was created using fractals, And if you might be the only person to stand at a specific point in the game because of its vastness, which is all due to its fractal nature, and it is very precise and clear and has a very high resolution because it was created using the infinite patterns of fractals.
Since fractals go on forever, they can be used to predict growth of urban populations, upcoming natural disasters, and the stock market.
When applied in biology, fractals can be used to predict the growth of bacteria or analyze the patterns of neuron axons and dendrites. And as you can see here, this is a bundle of a nerve bundle, and its dendrites and axons are composed of fractals. And when you zoom in on a specific segment of that dendrite or axon, you can see that it is composed of very small fragments that mirror the image of the shape of the larger segment, which is an example of a fractal that exists in nature.
The ability to use fractals is also important because it allows scientists to make medical breakthroughs. Also, they can help prevent severe weather and allow warnings to be issued, which in turn can save many lives.
Fractals also provide an intrinsic value to society since they can be used to create art through computer programs. They also create various appealing patterns in nature, which humans can easily notice because the human eye is trained to spot patterns, which can increase intrinsic value. And here's an example of fractal art. This one kind of looks like a snail shell, and if you were to zoom in on a specific segment of that snail shell, it has the same shape as the larger shell because of its infinite pattern.
In summary, fractals are a profoundly interesting topic.
As you can see, they are all over the natural world and make up the simple yet extremely complex patterns of nature.
They also have many technological applications in video games and movie animations and in art, and they provide patterns by which future society demographics can be predicted.
Thanks for watching this TED Talk about fractals. We hope that you'll join us next time for our next mathematics talk.
We hope you have a wonderful day.
Goodbye.